Hi everybody, this is video 2 for module 1, exponent rules, and in this video for math 0 to 4 we're going to look at the zero power rule, we're going to look at negative exponents, and then we're also going to do some problems where we put all of the rules that we've looked at together. So the product rule, the quotient rule, the power of a product rule from the first video. So for the zero exponent rule. The zero exponent rule says if you have any power or any base raised to the zero power, it's always going to equal 1 as long as the base is not 0. So if it's 0 to the 0 power, it's 0. But a to the 0 power, so any number other than 0 or variable raised to the 0 power always equals 1. And you're probably like, well, why is that? And I'm going to show you why it is. So remember our quotient rule where we had like x to the third over x, I'm going to make them the same, x to the third. Remember we subtracted exponents here? So if we did that, if I did 3 minus 3, I would get 0. So I would have x to the 0 power, which now we know is equal to 1. So this would equal 1. The reason it equals 1, remember when we were doing that quotient rule, I wrote out in expanded form, x to the third power is x times x times x. So we have the 3 x's there. And remember, if you have the same thing on the top and the bottom of a fraction, it equals a 1. So we have a 1 there, we have a 1 there, and we have a 1 there. So remember, 1 times 1 times 1 is all equal to 1. So that's why we had to come up with this rule, or we had to state this rule, that if you have anything raised to the 0 power, it equals 1. So here, if we're evaluating 17 to the 0 power, okay, it's going to equal 1. Now, if you look at B, remember, we have 17. If I write it out and look at it, it's really 17 times x to the 0 power. That 0 is only with the x, not with the 17. So we know that x to the 0 power is equal to 1. So now we have 17 times 1, or our answer is going to be 17. For C, we have 17 times x times y times z to the 0 power. Now again, z to the 0 power is the 0 is only attached to that z. So that's going to turn that into a 1, but we still have 17 times x and times y. So 1 times 17 is 17, and then we keep our x and our y on there. So that answer would be 17xy. Okay, so now for D. This one, we could do our product of a power rule because we have that 0 on the outside, and we could distribute it to everything on the inside, which it's going to make it 17 to the 0 power times x to the 0 power, y to the 0 power, and z to the 0 power. We know that 17 to the 0 power is 1. X to the 0 power is 1, y to the 0 power is 1, and z to the 0 power is also 1. So 1 times 1 times 1 times 1 is going to give us 1 for the final answer. Now E, they are looking at 17 to the 0 power, which we know is 1, plus 17 to the first power. Remember, that's just 17 because it's 17 once. So we can do the math here. 1 plus 17 is going to give us 18 there. Now, for F, this one's a little tricky because we have 17 to the 0 power, but then you have that negative. Because they did not include parentheses around that negative like this, it's not negative 17 to the 0 power. It is just 17 to the 0 power, and then take the opposite of it. So it's going to be 17 to the 0 power is 1, but because we have that negative sign, it's going to make it a negative 1. Plus 15 to the 0 power, anything to the 0 power equals 1. So we have negative 1 plus 1, and that is going to equal 0 in the end. So that's our zero power rule. And really the hardest thing is making sure you look at where is that zero attached to? What bases is it attached to? Is it attached to all of them? Only one? Multiple ones? So you really have to inspect that and figure that out before you evaluate to find your answer. And that is it for the zero power rule. And now we're going to look at negative exponents. Okay, so now we're going to do the negative exponent rule. And with math, again, mathematicians, there are certain things we don't like. We can't have zero in the bottom of our denominator. We also, negative exponents, we always want to simplify them with positive exponents. So math rules wise, if we come across a negative exponent, the way to make that exponent positive, anytime you have a negative exponent, is to take the reciprocal of that power, and that will turn the exponent into a positive exponent. So again, remember, any power that you see without a fraction bar is really like a to the negative nth power. It's like a to the negative nth over 1. So in order to make it positive, you take the reciprocal, which, remember, the reciprocal is when you flip the numerator and the denominator. So let's take a look at some problems here. And we're going to start off with 4 to the negative third power. So again, because I have that negative 3 and we want to turn it into positive, and you'll see when the directions for exponents come up, they'll ask you to always simplify using only positive exponents. So we have to turn those negatives into positives. So if I put 4 over to the negative third power, if I put 4 to the negative third power over 1, then what I can do is flip the 2, and that will make that negative 3 positive. So now my answer is going to become 1 over 4 to the third power. And I've made it into a positive exponent. So we can stop there, or sometimes they'll ask you, because it's 4 to the third power, to multiply that out, so it becomes 1 over 64. Again, either way, these are both acceptable. It depends on if it asks you to evaluate those powers. If it does, we do 4 times 4 times 4. All right, let's take a look at B. Okay, I have 2 powers, both with negative exponents, so I am going to flip both. So it's going to become 1 over 2 to the third power plus 1 over 3 to the first. Now, I could put that 1 there, but I don't really have to. Now, we do have a math problem here where I have to add fractions. So I am going to make this 2 to the third power, 2 times 2 times 2 is going to give me 8. So 1/8 plus 1/3. And we can simplify that and evaluate it. We can add those fractions. But if you recall, to add fractions, you have to have a common denominator. So 8 and 3 have a common denominator of 24. And to get 24 out of 8, I multiplied by 3. So we're going to do 1 times 3. And to get 24 from 3, we're going to multiply times 8. 1 times 8, so it's going to be 8 24ths. And then we add those two numerators together, and we end up with 11 over 24 for our final answer. All right, let's take a look at C here. So we're starting off with 2 to the 0 power, which I know equals 1, minus, again here, I can, they're negative exponents, so I can flip it. So it's going to become 1 over 2, or 2 to the first, but I don't need to put the 1 in there, minus 1 over 2 to the second when I flip it. So that's going to give me 1 minus 1/2 minus that 2 to the second becomes 1/4. Again, I can make these all have a common denominator of 4. 1, remember that whole number 1? If I'm using a denominator of 4, it becomes 4 over 4 because the same thing on the top or the bottom equals 1. So I'm going to have 4 over 4 minus, to turn 1/2 into 4, I multiply by 2 on the top and the bottom, so it becomes 2/4. And I already have my 1/4. So when I do my subtraction, 4 minus 2 is 2. 2 minus 1 is 1. So my final answer there is 1/4. So a little fraction review in there with those negative exponents. All right, and so for here, we're going to continue with our negative exponents and simplifying so we have positive exponents. Now we have -6 to the -2nd power, and we know it's the whole -6 because they put parentheses around it. So again, I'm just going to flip it. I'm going to put the 1 underneath. Now, when I flip this, it's not going to change the base. The base is still going to remain negative. It's only the exponent that becomes positive. So my answer here is going to be 1 over -6 to the 2nd power. So the base, when you flip it, doesn't change signs. If it's negative, it stays negative. Only the exponent becomes positive. And then again, we can simplify this by doing -6 to the 2nd power. So -6 times -6 will end up being 36. So I have 1 over 36. Now for E, we can do our power of a quotient rule if we want and distribute that -4. So we have 2 to the -4th power over 3 to the -4th power. And then to make them positive, we take the reciprocal. So we flip both the top and the bottom. So we get 3 to the 4th over 2 to the 4th. And then you can simplify by doing 3 to the 4th power. So 3 times 3 times 3 times 3 is 81. And 2 times 2 times 2 times 2 is 16. And then you want to see if you can simplify that fraction, but we can't simplify it. So we're done there. We're all done. F, again, we're going to do the same thing. Now, the negative is down like by the fraction bar. You can, when you have a fraction, like we have -4/5, you can write it in the numerator, you can write it by the fraction bar, or you could put it in the denominator. But for us, I think it's easier. I'm going to focus on it up with the numerator. It's typically where we envision it. So I'm going to put it -4 over the 5th power over 5 raised to that -3rd power. So again, I'm going to distribute that -3. So it's going to become -4 to the -3rd power. And I do need to put parentheses around that -4. And then 5 to the -3rd power. So again, I can flip the 2. So it becomes 5 to the 3rd power over -4 to the 3rd power. And then again, we can multiply that out. 5 to the 3rd power is 5 times 5 times 5, which is 125. And -4 to the 3rd power will be -4 times -4 times -4. And that is going to give us 64. Now, if we could simplify the fraction, we would, but there's nothing we can divide out of that. There's no common factors. It is a mixed number like the 81 over 16, but you'll find that mixed numbers are okay as long as they're in simplest form. We don't often turn them, or it's an improper fraction, excuse me. We don't often turn them into mixed numbers because oftentimes if we have to multiply or divide with them, they need to be improper fractions. So we're going to leave them in improper form. All right, so the last thing we're going to do is we're just going to look at some different problems and apply all of the rules for exponents. So we're going to look at them. Now, the nice thing about rules for exponents is we have all those different rules, and but the thing is you can apply them in different orders. So sometimes the way I do a problem may not be the way you would per se do it, but you still get the same answer. So it's sometimes just a matter of which rule do you apply first or which one do you look at. So we're going to kind of talk about that as we solve these problems. Now, for the first one, we have negative exponents, and then we also have division here. So I'm going to need to use probably my quotient rule. So I'm going to need to do some subtracting and get rid of those exponents. So I can do it two different ways. I can start off with my quotient rule if I want. So again, I would subtract those exponents. So it would be -2 minus -5. And remember, when we do that, when we subtract with integers, it's like addition of the opposite. So it's really -2 plus 5. And that's going to give me x to the third power. So now, because I did the quotient rule first, I got x to the third power and I'm done. Another way to solve that would have been, oh, I see these negative exponents, I'm going to flip it first. And if you had done that, you would have had x to the fifth over x to the second. And then if you subtracted those exponents, you would get x to the third power. So just different ways to do the problem. Now for B, we do need to apply the power rule first. We want to do that. So we're going to end up with B, 2 times 3 is 6. So we're going to have B to the 6th power over B to the 20th power. Then we can do our quotient rule. So B 6 minus 20. So if I have 6 and I take away 20, I'm going to end up with -14. And then remember, the directions say they want a positive answer, positive exponents. So again, because I have that negative exponent, I'm going to flip it, and my final answer will be 1 over b to the 14th power. So that one, when we solved it, it kind of gave us another rule that we had to do because we had that negative exponent. All right, so for C, we definitely want to do the product of a power rule first. You always want to start with that distributing. So we want to distribute that -3 to everything. So we're going to end up with 2 to the -3rd power. C, so 2 times -3 is going to be -6. And then D, -4 times -3 is going to give me D to the 12th power. Okay, again, we need positive exponents. So if I think of all this, remember, there's no fraction bar. You can put a fraction bar in a 1. This time, all my exponents aren't negative. Some are, some aren't. So because this d to the 12th is positive, it's going to stay on the top. But the 2 to the -3rd power and the c to the -6th, they need to move to the bottom. So what I'm going to do is I'm going to rewrite it as 2 to the -3rd power, or excuse me, 2 to the 3rd power, because remember I moved it, so it becomes a positive exponent. So we have 2 to the 3rd power, c to the 6th power, because I moved it down, and then we'll leave d to the 12th on the top. And then the only other thing I can do here is that 2 to the 3rd, I can multiply it out and make it 8, c to the 6th, and then d to the 12th on the top. Now, I can't apply like the quotient rule here because my bases of D and C are not the same. So if your bases aren't the same, we can't use that quotient rule. So this would be our final answer. Okay, so now we're going to take a look at D, and this one I'm going to start off and do that quotient rule because I can see there's that fraction bar in there, and we have bases that are the same, so like x to the 3rd and x to the 6th. So again, we always start with the top power minus the bottom one. So it's going to be x to the 3 minus 6, or we're going to get x to the -3rd power. And then for y, it's going to be 7 minus 5. So we'll end up with y to the 2nd power. Now again, I have one negative and one positive exponent. So we need to turn the negative exponents into positives by moving them below, putting that fraction bar and moving them below. But any positive exponents are going to stay on the top. We're not going to flip the whole thing, only those negative exponents. So my final answer is going to end up being 1, or not, excuse me, not that 1. We're going to flip that x to the -3rd to the bottom. So I'm going to have y squared on the top and x to the -3rd on the bottom. And that will be my final answer, except the negative is not there anymore because I moved it to the bottom, so it becomes x to the 3rd power. It becomes positive. So don't make the same mistake I made. When you move it to the bottom, make it positive. Okay, for E, here we have, again, we start off with the fraction, and then it looks like we're going to do the quotient rule again. We're going to do it quite a bit on this page, it looks like. So -24 over 18 is really just like a fraction that we need to simplify. And I think, let's see here. What goes into both of those? The biggest number I can think of is 6. So I'm going to divide them both by 6. So negative 24 divided by 6 will give me negative 4. And then 18 divided by 6, which I know I didn't write it very well, is 3. So negative 4/3. Now let's do our subtracting here. We have bases that are the same, p, 6 minus 10. And again, whenever you subtract, it always brings it up to the top or, off to the side. But I'm going to put it on the top of the fraction. So we're going to have p to the negative 4th power. And then q to the 9th divided by q to the 12th. 9 minus 12 is going to give me a negative 3. So now when I go to do my answer, remember, any negative exponents you want to flip. So if they're on the top, you bring them to the bottom. If they're on the bottom, you bring them to the top. But this negative 4/3, that's a negative 4, not a power. So it's going to stay right where it is. The 3 is going to stay right where it is. But the p to the negative 4th, we move it to the bottom, so it becomes p to the 4th. And the q to the negative 3rd becomes q to the 3rd power. We move it to the bottom. So there's our final answer. It's negative 4 over 3, p to the 4th, q to the 3rd. All right, let's see here. So for f, we can do the same thing. We do that quotient rule again. We just got to deal with negative signs. So 10 and 12, I can divide them both by 2, and that's just simplifying that fraction there. So we're going to have 5/6. And then now for s, we're going to do negative 5 minus negative 9. So again, we're going to do addition of the opposite. Negative 5 plus 9 is a positive 4. So we have s to the 4th power. And again, if you're not remembering the rules for positive and negative numbers, look up rules for integers and subtracting integers, multiplying and dividing if you need to. Now for t, it's negative 4 minus negative 2, so it becomes plus a positive. And that becomes negative 4 plus positive 2 will give us t to the negative 2nd power. So again, we're almost done here, but we have that negative exponent, and we always want positive exponents. So if it's negative, you got to flip it or bring it, if it's on the top, bring it to the bottom. If it's on the bottom, you bring it to the top. So now my final answer is going to be 5 s to the 4th power over 6 t to the 2nd, because remember, when you bring it down, it makes it positive. Okay, so now we are on our last 3 problems that we're going to work through. And the first thing we're going to do here is we are going to do the power of a quotient rule. So we're going to distribute this negative 3 to everything in the numerator and the denominator. So x squared times that negative 3, 2 times negative 3 is going to give me x to the negative 6th power. And then negative 4 times negative 3 will give me y to the 12th power. Now, down at the bottom, we actually have to do a double distributing here. Or actually, never mind. That negative 3 is everything on the top because it's in the parentheses. The negative 5 goes to everything on the bottom. My apologies. So we're going to have x to the negative 5th power and then y to the negative 5th power because we distributed everything in those parentheses. Now we can go ahead and do our quotient rule. So for x, we're going to do negative 6 minus negative 5. So that becomes plus a positive. So it's x to the negative 1st power. And then y is 12 minus negative 5. So it's 12 minus negative 5. So again, addition of the opposite. That becomes y to the 17th power. So this is what we have right now. But again, we can't have that negative exponent. So we've got to move that x to the bottom. So remember, it's like everything is over 1. If we need to turn any term into a fraction, you put it over 1. And we're going to move the x to the bottom. But the y to the 17, it's positive, so it stays at the top. So our final answer is y to the 17th power over x, or x to the 1st power, but we don't have to put the 1 in there. So that's our final answer for G. It wasn't too bad. It looked horrible, but it wasn't horrible. All right, for h, let's start again by distributing the 2 to everything in the numerator. So I am going to have c to the 12th, because I'm doing, again, my power rule, d to the negative 14th. And then on the bottom, we're going to distribute the negative 14. So it's 2 times negative 14 will give me c to the negative 28th power and d to the negative 14th power. So now I want to simplify this. I can start off. One thing I do recognize, I do have negative exponents, but I have d to the negative 14th over d to the negative 14th. Because these two are exactly the same, they're going to cancel out, or they're going to equal a 1 because they're exactly the same on the top and the bottom, remember? So when they are exactly the same on the top and the bottom, it's going to give us a 1. So really, it's c to the 12th times 1 now. So we can, remove the d's. So now I just have to focus on, I have c to the 12th over c to the negative 28th. So we're going to do 12 minus negative 28. So again, addition of the opposite. So we're going to end up with c to the 40th. Because when you add 12 plus 28, you get 40. So that's our final answer. We got rid of that negative exponent by doing the subtraction. So we have c to the 40th power. All right, let's tackle our last problem here, and this is I. So again, we're going to have to start off, distribute, and now this negative 2 is outside the whole fractions. We have to distribute it to everything on the inside, numerator and denominator this time. So we're going to end up with 18 to the negative 2nd power. A, negative 2 times negative 2 is going to give me positive 4. B, negative 3 times negative 2 is going to give me b to the 6th power. Okay, and then on my denominator, I'm going to have 16 to the negative 2nd power. A to the negative 20th, because one negative and a positive gives me a negative. And b to the 8th power, because negative 4 times negative 2 is positive 8. Okay, so 16 and 18, their bases aren't the same, but I know that I have negative exponents there. So what I'm going to do with that is I'm going to go ahead and flip those. So I'm going to make it 16 to the 2nd power over 18 to the 2nd power. And then for the a's, I think I'm going to do the quotient rule. So I'm going to do, to start off, I'm going to do 4 minus negative 20. Because when I do that, that is going to end up giving me a positive value, a to the 24th power. And remember, anytime you do the quotient rule, it moves it up to the top of the fraction if there's that fraction bar there. And then b, if we do that right now, it's going to be 6 minus 8 will be b to the negative 2nd power. So I do have some work to do here. The first thing I'm going to do is, once I have those positive exponents like 16 to the 2nd power, I want to see if I can simplify that. So I know 16 to the 2nd power is 256 because it's 16 times 16. And 18 to the 2nd power is 324. And then my a to the 24th, I'm going to leave it on the top. But that b to the negative 2nd, because it's negative, I'm going to bring it down to the bottom. So this looks pretty good and done, except I do know that the 256 and 324, I can simplify that. And I can divide them both by, I think it is 4. Let me just double check. 256 divided by 4, 64, yep, and then 324 divided by 4 is 81. So what I did to simplify the 256 and the 324, I divided them both by 4. So when I did that and simplified those, I ended up with 64 over 81. And then we still have the a to the 24th, b to the second, because I couldn't do anything with those. So those are all of our problems simplified. So some different problems using multiple rules at one time. And again, depending on your problem, depends on what your problems look like when you see them and how they are and how we have to, differentiate between them. So hopefully you had some good practice out of this. And the next video, and this is the end of the second video, part 3 will deal with some applications with exponents. See you later.